Hello, this is Team Future Innovations, and we're working with Real Time Optical, and our sponsor is Ken Varga, and our mentor is Dean Klosiak, and our project is HUDsphere. And my name is Ty, this is Wilson, this is Amro, and this is Brian.
Hi, I will be talking about the project description to give you guys a little bit more insight on what our project exactly is and the motivation behind our project. We will also be talking about the hardware that we are using for our project, as well as the software utilized to achieve our goal for this project. In the end of this video, we will be giving a quick demonstration of our project. For our project description, the description of our project, we are to create a proof of concept to demonstrate total collision avoidance system, also known as TCAS. What TCAS is essentially is two planes sending wireless data to one another, displaying its location of where it exactly is. To demonstrate this, we will have a computer and as well as the HUD box, which will pretend to be our plane and receiving the other plane's data, which is the computer over here.
Alright, I'm going to talk a little bit about the hardware that we're using for this project. This here is what we call the HUD box, and basically it's just an Intel Atom processor. It's a development kit, and it has a 32 gig SSD hard drive in it. Also has 2 gigs of RAM, so it has plenty of memory. And also we have a USB wireless card here. And then here we have a laptop here that is, this is the server here. And the server here will send the plane data wirelessly to the HUD box, and you can see that because we don't have any cords whatsoever hooked up to the laptop. And now I'm going to talk about a little bit about the software that we have in the HUD box. One of the requirements was from the mentor was to have a lightweight operating system installed. So we use Lubuntu, which is a lightweight version of Ubuntu, and basically it has the minimum amount of services that we need to run the operating system, and so that also conserves power, and we have better performance. And also this Intel Atom board in here, we chose that because the mentors also wanted a low power requirement.
What I'm showing you right here is the server side of our project, and what this does is it inputs plane data and sends it wirelessly to the HUD box to be displayed by our GUI. And the type of data that's sending is the plane's ID, the aircraft to AI bearing, which is the relationship of the aircraft towards our aircraft and bearings, the altitude of the plane, the AI bearing, which is the direction that the plane is traveling, the distance, how far the distance the plane is compared to our position, and the vertical motion of the plane, whether it's climbing or descending. And once we have all those inputted, we just hit enter button, and then it's sent wirelessly to the HUD box. What we're going to show you right now is our 2D version of the GUI. We have a 2D version and we have a 3D version. The 2D version, Amber's going to show you inputting aircraft data. What we're going to be inputting is the aircraft ID, and with American Airlines 293, a distance of 4 nautical miles, and it's going to be climbing. Go ahead, Admiral, and input it.
Alright, so I'm going to hit the enter button to send the data.
And what the graph right now is displaying is an aircraft going at 0 degrees from our aircraft, and it's ascending 1,000 feet above our plane with the plane ID American Airlines 293.
Alright, I'm going to change the settings on this airplane. I'm going to send another airplane to the monitor.
And this airplane he's sending is far out, so it's not a threat to our plane right now. So the symbology is a white diamond, which means it's safe. As it gets closer to our plane, which is right here, the symbology changes at nautical mile increments. So it'll change to a blue diamond, then it'll change to a yellow circle, and then if it's a red square, that means it's a hazard and the plane either needs to pull up or find another way, move out of the plane's direction.
Meanwhile, we can show another.
And he's going to go ahead and then put another plane into the radar. We have another airline and it's going 90 degrees away from our aircraft, and it's ascending at 1,000 feet above our plane. What we're showing you right now is the 3D application of our project, and what this is going to show is the elevation of the plane in first-person perspective. So it's Admiral inputted the plane, and it's American Airlines 293 with the nautical miles of 1.36, and it's climbing. And it's going to keep the out-of-screen indication as it's leaving the border so that it stays on the edge of the screen. And it has a TCAS symbology, so yellow square has the white diamond, the blue diamond, and the red square. We have another plane right here. This one's also climbing at 1.10 nautical miles out. And Admiral's going to input another plane in. And we have another plane, and this one's a hazard plane with the red square, which indicates that our plane needs to move directions immediately. And that one is descending with a distance of 0.76 nautical miles, which is really close to our plane. And another aircraft, also close to our plane, with a distance of 0.84 nautical miles. So this is our 3D demonstration of our TCAS 3D version with a first-person perspective.
To conclude, we talked about our project description, hardware, and software. And we talked about how hardware and software interact with each other. And we also showed a quick demo of how our project works. And thank you for watching.